This is the short version of practice problem number 4 from lesson 6, describing transformations, and unit 1, rigid transformations and congruence. This is a nice review of the 3 transformations that we've been studying: a translation, a reflection, and a rotation. So you're going to take the same quadrilateral, and this is a basic quadrilateral in that all 4 sides are different lengths and all 4 angles are different sizes. So you're going to take the same quadrilateral, you're going to translate it, and you're going to go back to the same quadrilateral and reflect it, and then you're going to go back to that same quadrilateral and rotate it. For the first transformation, a translation, you're going to take this quadrilateral and you're going to move this point B over to the same place as this point D. So you're going to translate it, you're going to move it from B to D. So a translation means that this quadrilateral is going to move in a straight line. There's going to be no twisting, no turning, no reflecting, just a straight movement. So you can imagine a straight line drawn from B to D, and this quadrilateral is going to move along that straight line, keeping A and C in their same relative position. So here is the quadrilateral translated from B to D. So let me show you how that movement works. So I drew a straight line, and this quadrilateral is going to move along that straight line. So a straight line along A, a parallel straight line along C, and another parallel line along B through D to the opposite side. So this quadrilateral is going to move along those parallel lines until B lands right on top of D. So this quadrilateral now has been translated from figure A, B, C, D to the image of that figure A prime, B prime, C prime, and D prime. The second transformation is a reflection over line segment BC. So a reflection over this line segment, or this side right here, BC. Because the transformation is a reflection over BC, it means that points B and C are going to stay in the same position. But what's going to move are points A and D, and they are going to move perpendicular to the line of reflection. That means they're going to form a 90-degree angle with the line of reflection and move an equal distance on the other side of the line of reflection. So an equal distance on the other side of the line of reflection. So you connect these points. So this is A prime, B prime now, C prime, and D prime. This is a reflected image of figure A, B, C, and D. The third transformation is a rotation around point A. So point A is the center of rotation, and the size of that rotation is angle DAB. So DAB. And the rotation is counterclockwise, so the opposite direction that a clock moves, counterclockwise. So a rotation around point A, and the size of that rotation, or the number of degrees of that rotation, is angle DAB. So here's angle DAB. Figure ABCD is going to rotate counterclockwise, so the direction opposite of a clock. Now angle DAB, if you just take side AD and rotate that side up so that it covers side AB, that is the angle DAB. So this figure will now have rotated the size of that angle, DAB. So this is B prime, and so B has rotated, again, the size of DAB. So it's rotated from here to here. So this is B prime, this is B to B prime. Point C rotates that same number of degrees from here to C prime. A little bit harder to see that it's the same number of degrees. You could use a protractor and measure it, or trace it and rotate a tracing. So trace this angle right here, DAB, and rotate it and show that the size of this angle from C to C prime is the same, and the size of the angle from B to B prime is also the same. And finally, D rotates to D prime, and that's pretty easy to see. It is that angle DAB. So here is A prime, B prime, C prime, D prime. That's a rotated image of figure A, B, C, and D. Rotated counterclockwise, the size of angle DAB.